Hello, and welcome back to Mr. Powers Teaches Algebra. We are going over sequences, geometric sequences. We just defined those. Here's our definition for them. Excuse me. I muted the wrong thing. Okay. So there they are. They have a common ratio. To get one term, we multiply by the same thing each time to get our next successive term. All right, and we have a couple examples here that we went over. So now what? Now, of course, what we always want to be able to do is to create an explicit formula for these guys, just like with arithmetic sequences, because those are going to give us some tools for finding, let's say, a common difference or a common ratio between the fifth term and the 25th term. Let's say we only know those two and we want to find the common ratio. Well, an explicit formula is going to help us with that. Or a common difference if we're doing arithmetic, same thing. Our explicit formula makes that very easy. It turns it into solving equations or solving a system of equations. Super easy then. So let's do it. Let's go ahead and find an explicit formula for this guy. I'm going to do it the same way I did with arithmetic sequences. Right? This is my a sub n. Okay, that's right here. And I want to find a formula. I don't want to have to write term by term and then ellipses and say, keep the pattern going. I want to have a formula, an equation. So, an expression here. This is my first term. This is n equals 1. This is n equals 2, my second term. This is n equals 3. This is n equals 4. Now this one is so obvious. I think it's even more obvious than it was for our arithmetic sequences. Check this out. So again, this is my A1. This one, look at this too. I mean, look, there's A1 in each of them, right? Here's my A2. But I'm going to go ahead. I'm just going to rewrite it. This is my second term. Oh. Excuse me. Okay. This is my second term. And I have r to the 1. This is my third term. I have r squared. This is my fourth term. I have r cubed. I could write this term, a sub 1, as r to the 0. Okay. And here, just to make these differentiated a little bit. My second term, I could rewrite a sub 1, r1. And then my third term, a sub 1, r2. And then my fourth term, a sub 1, r3. So that's super easy. How is my n related to my, because remember, this is n, yeah. How is my n related to the expressions here? Easily. It's like all these are exactly the same. The only thing difference is the power. The power here, 0, is 1 less than 1. Here the power is 1 less than 2. Here the power is 1 less than 3. That's our pattern. It's obvious. And so without going through a proof, I'm just going to go ahead and say, you know what? Here it is. We are going to get that this guy is we could go ahead and, again, I could say, you know what? This is really r a sub 1 r to the 1 minus 1. This is a sub 1 to the times r to the 2 minus 1. This one is a sub 1 times r to the 3 minus 1. Now it's really obvious how my n is related to my expressions here. So if I haven't gone slow enough, here's our explicit sequence for these guys. A sub n is going to be a sub 1 times r to the n minus 1. That's it. And that is our explicit formula for geometric sequences. where R is our common ratio, right? And A sub 1 is our first term. And that'll do it. That's it. Okay? So there it is. That's how we find this wonderful formula. And without further ado, I think that'll do it for this video. In our next video, we'll go ahead and use this formula to find some explicit formulas for a geometric sequence or two. So until next time, enjoy doing math.